Let's extend our definitions to include the four other trigonometric functions. So far on the unit circle, we have cosine of t is x and sine of t is y. So how do we write the other four trig functions using x and y if x and y correspond to a point on the unit circle? Okay. Well, the first thing we can do is just use some of the identities that we've already established. So one is the quotient identity that says that the tangent of some angle t, we'll keep using t here, is sine of t over cosine of t. And we know that sine of t is y and cosine of t is x. So we just get tangent of t is y over x on the unit circle. Okay, great. All right, what about secant of t? Well, secant of t is just 1 over cosine of t. That's one of our reciprocal identities. So that's just 1 over x. Cosecant of t, that's just 1 over sine of t. So this is 1 over y. And cotan of t is just, let's see, 1 over tan t. So that just really means take the output for tan and flip it. So instead of y over x, we have x over y. And so that's how we can express these four other trig functions using coordinates from a point on the unit circle. So let's try it out. Let the point 1, 2, comma, negative root 3 over 2 be a point on the unit circle corresponding to the angle theta. So evaluate the 6 trigonometric functions at theta. So we could go and actually find out what that angle theta is and do some work, but here we don't even need to because we are defining our functions just based on the x and y. So far we have x equals 1/2 and y equals negative root 3 over 2. And again, they're telling me that this is on the unit circle, and that's the important part. If we weren't, to do something else, but we're on the unit circle, so off we go. So here's my x and y, and so I'll just start out. I'll say, okay, well, I know cosine of t is just equal to x, and that's 1/2. I know sine of t is equal to y, which is negative root 3 over 2. For tan of t, I can still use the fact that it's y over x. So I have, let's see, negative root 3 over 2 divided by x. That's divided by 1/2. That's the same thing as multiplying by 2. So I get negative root 3. All right, I'll keep going. Secant of t. So I could still use, I could say, well, that's just 1 over cosine t and kind of go from there. Or I can use the definition that we just did. Secant of t is 1 over x. It'll all work out the same. 1 over x, that's the same as 1 over 1/2. That's just flipping 1/2 to be 2, right? And what I could have done maybe even quicker than our new definition allows for is that secant of t is the reciprocal of cosine. So I go, oh, this is just going to be this flipped. So I could have known that that was 2 kind of almost immediately. Or I could use a new definition just since that's what we're practicing right now. So there's multiple ways to get to the right answer, which is never a bad idea. So cosecant of t, we said that is 1 over y. So that's 1 over negative root 3 over 2, but I know that just is going to flip it around. So keep the negative, but negative 2 over root 3. I want to rationalize that denominator to give me negative 2 root 3 all over 3. And then lastly, I got to find room for my cotan here. All right, cotan of t, we said that's x over y. So that is 1/2 divided by negative root 3 over 2 is the same thing as multiplying by 2 over root 3, but I want to keep that negative there. So I get negative 1 over root 3, and that makes sense. This is just the reciprocal of the tan value. So here's my tangent value. So it's just 1 over that. That's good. But I don't want to leave it like that. I want to rationalize the denominator. So I end up with negative root 3 over 3.